All right, we're back for some examples in section 7.1, looking at the central limit theorem. This example is looking at an unknown distribution, average of 90, standard deviation of 15, and a sample size of 25, randomly drawn from the population. Find the value that's 2 standard deviations above the expected value of 90, the sample mean. So to do that, we want to find 2 standard deviations above 90. So for that, what we're going to be doing is looking at, once again, the sample standard deviation. So here's our average, 90. Number of standard deviations, they're looking for 2 above 90. And instead of using our standard deviation of 15, we take that 15 and we divide it by the square root of the sample size. So square root of 25, which would be 5. So 15 divided by 5 would be 3. 2 times 3 is 6. 90 plus 6 is 96. So that's how they come up with that number. Length of time, new problem. Length of time in hours. It takes an over 40 group of people to play one soccer match, is normally distributed with a mean of 2 hours and a standard deviation of 0.5 hours. Sample size of 50 is drawn from the population. Find the probability that they play between 1.8 and 2.3 hours. All right, so we list our items again. Average, 2. Standard deviation, 0.5. Number of values or sample size, 50. So we use our formula again. Same average. And the standard deviation always divides by the sample size to get our sample standard deviation. So we take that 0.5 divided by square root of 50. For that, you'd probably need a calculator because the square root of 50 is like 7.1 something. All right. So from there, we go ahead and put that into our calculator. So let me go through that. So 0.5 divided by the square root of 50. I'll type that in here. SQRT, square root of 50. And 0.5 divided by that square root of 50, so 0.0707. All right. So our average is 2, and our sample standard deviation is 0.0707. So I go back into my calculator here. 0707. And what are we looking for? Between 1.8 and 2.3 hours. And there we go. Well, looks like almost all of it. 0.9977. So 99.77% of the time, they've played between that many hours, which makes sense because this is a really small standard deviation. And when we make it even smaller with a pretty decent sample size, it gets to be a very narrow window, which we can see here. The graph, you can see our numbers here. 1.8 and 2.3 falls with it between most of our graph here. So almost 100% of the time. All right, that's it for now.